we have a last speaker before the lunchtime. We are running a little bit late, but not so much, so I think it's fine. And so we need to be ready that we are now going to dig into the real problems to me, which is we have talked a lot about climate crisis and biodiversity, but this is mainly and most likely not the main problem. So we are going to start talking about land use, and for this we have a gifted scientist here at UCL who has also helped me very much with preparing this day. And so Patrick Meffroy, you have been hired as a permanent research scientist at the FNRS in Belgium. You have an ERC, which is a wonderful European grant, and you have also a very interesting background by being both trained in sociology and also then in geography. And so you are interested in land use transitions, and your main research includes land use for forest use, linkages between globalization and land use, and then social ecological feedbacks. And all this, I think, is really like very timely for us right now. Thank you very much.
Okay, so I know it's late. It's been already a long morning with a lot of information, so I will try to not take too much of your time yet before the break. But I wanted to speak a little bit about land use, so because we've heard from Ralph already in the first talk that it is a major driver of biodiversity impacts as well as climate change and interacting with it. I'm not going to talk too much actually about the impacts. Okay, is it better? You still here in the back? No. Okay. So I'm not going to talk too much about directly the impacts of land use change on biodiversity, but we will hear, I think, more about that also in the afternoon. But I will try to take a step back and think about a little bit what do we mean by land use and what's driving it in the end. So most of my key messages come from these reports that we've already heard about, although sometimes the examples are not coming from these reports. And I will start by trying to make just 3 key points about the diagnostic, and then I will try to have 3 key points about the responses and what we can do. Okay, the first point is when we talk about land use, I think it's first important to try to see how we can analyze this, and we can decompose land use change. This is a figure from the IPBES report on land degradation and restoration, and we can decompose land use and its impact on ecosystems between, on the one hand, there's some kind of land use activities which are really what we can call land use conversion or transformation, which is really transforming an ecosystem into a completely different ecosystem, a natural ecosystem into a different kind, like transforming a forest into a cropland area. But we also have forms of land use, land changes, which we can call more land management changes or modifications. So where we will have a gradient of different practices which will have an impact on ecosystems and on biodiversity, but without completely transforming the ecosystem into a different one. So this can happen in natural ecosystems as well as in transformed ecosystems. We have a gradient of management practices which often relate to variation in intensity of the management, and it's important to separate these 2 aspects, because oftentimes we realize that what we can do about land use and how we measure the impacts of land use is about balancing these trade-offs between expansion, conversion of ecosystems, or management and impacts of more intensive management of ecosystems. Okay, if we look at the global land use perspective, this is a figure from the IPCC report on land, which distributes the global terrestrial ice-free land surface into different categories of land cover and land use, and different gradients of intensity of management. And what we see is that we find again this difference between conversion and modification of ecosystems. So I'm not going in the details of the figure, but overall what we have is we have about a quarter of the terrestrial land surface which has been converted by human to another kind of ecosystem. This is essentially forests converted to cropland or grasslands for pasture and grasslands converted to cropland. We have gradients of intensity within this this converted land, so very few portions of the land surface which are used very intensively, so 1% of the land surface for infrastructure, urban areas and things like that, 2% of the land surface for very intensive irrigated croplands and things like that, so very small portion used very intensively, but much larger portions used more extensively. But we also have about half of the terrestrial surface which has not been converted to a different kind of ecosystems, but which has been modified because of land management by humans. So that's about 50%, half of the land surface, and this is essentially forests that are used for exploiting timber, logging, hunting, harvesting a series of products, modified by human-made fires and things like that, and to a large extent also natural grasslands that are used for grazing. So all in all, it's only about 24%, a quarter of the land surface which is not impacted directly by land management or land use, and half of this remaining quarter is land which is essentially unproductive land, so bare rocks land, so it's only about the 12% remaining which is unmodified directly by land management. Of course, it can be modified by climate change also. So we see also this distinction in the, if we measure the impact of human on plant biomass. So from the total vegetation that could exist on the planet potentially, based on vegetation models and so on, we currently only have about half of that amount of vegetation left. The other half has been removed by human activities, and if we take this same data and we split this by biome and we try to see what is the share of this impact on biomass which is due to converting ecosystems versus modifying ecosystems, it's about half-half. So what we have in the bars here is different biomes on the planet. The total bar is the potential vegetation that could exist. In total, the green is what is remaining, and the yellow and the blue bars are respectively the amount of biomass lost by converting ecosystems versus managing ecosystems but that remain non-transformed. So it's about half-half. So the key message, first key message is we have a planet that is already largely used, especially if we count not only for the conversion of ecosystems, as we often do, but also we account for the management and the modification of ecosystems by land management. And the impacts of both are of the same order of magnitude. Second key message, land use is increasingly driven by distant factors, distant processes, which relate to international trade, for example, but not only international trade. And so the impacts on biodiversity and as well as on other environmental parameters are increasingly, of course, they are produced locally by land use and land management practices, but the drivers of these land use and land management practices are increasingly distant. So this is just a figure, a review paper that tried to quantify the amount of impacts on a range of different environmental indicators which are related to international trade, and depending on the different indicators, biodiversity, water pollution, carbon emissions, and so on and so on, they find that between 10 and 70% of the environmental impacts are related to international trade. Of course, ultimately, trade is related to consumption, and so this is a graph which shows the total amount of material use, which is, well, material flows that are used to serve consumption from EU population, what you have in the orange line, which is relatively flat, is the amount of material flows that are used domestically within Europe. And you see that this is relatively flat, so in some extent it corresponds to what Jean-Pascal was saying. We can have economic growth and a relatively stable amount of material flow used within Europe, but if you account for the material flows that are used outside of Europe but serve European consumption, you have the different stacked bars there, and you see that this is continuing to increase. Okay, just a few numbers about one of the key land use change processes that impact biodiversity, which is tropical deforestation. And so it's, again, to highlight a little bit the importance of international trade and distant drivers in this process of tropical deforestation. So about a quarter of the tropical deforestation can be directly attributed to the production of goods that are that enter international trade at some point. You have the numbers for Belgium. I was thinking maybe it could be interesting for some. So every year we can attribute directly the consumption of products in Belgium which are produced in tropical regions. We can attribute that it's responsible for about 12,000 hectares of deforestation every year. So it doesn't look like a big thing if you compare to the size of the country, but it's only the new deforestation every year. So if you accumulate that over 10, 20, 30 years, it starts to become something. Okay, so I'm not going to spend a lot of time on this, but we do have an increasing knowledge and increasing number of studies that are able to trace these flows of products through international trade, to relate that to biodiversity impact and to map that. So this is a map from a study that represents here the impacts on biodiversity that are related to products that are consumed in the United States. So of course, the impacts outside of the United States. So United States is white, and so the impacts there. So the color of the figure, the intensity of the color depends on the amount of species threats in these places and the amount of products that are exported to United States and products that are having an impact on these species. So globally, so it makes about 17–30% of the biodiversity loss, which is linked directly to international trade, but it's much more in some regions. So in developing countries, it's about 35–60% of species threat. So it's very rough numbers still, and of course it depends very much on how you measure your biodiversity. But okay, it's an ongoing frontier for research. So what it means is that in some regions it's a very important share, and because much of that is related to trade that ends up in high-income countries, it's important to notice that even though it happens in countries far away, it is something on which we in principle could have leverage. So okay, that's my second key message. My third key message is when we try to understand how land use processes happen, and so what we can do about that to have less impacts on biodiversity, we quickly realize that land use processes are complex. So you don't always easily predict what's going to happen, and when you put policies in place, it's not obvious that you're going to have the effect that you were intending to have. And I'm just going to illustrate that with some examples. The first example is, well, in Vietnam, in the 1980s, there was a very rapid deforestation especially in the northern region of Vietnam, which is an important place for biodiversity. There was also food security issues, so the government decided to put put a lot of policies in place and responses, and among these responses, they put a big emphasis on improving agricultural productivity in the paddy fields, so in the irrigated rice fields in the mountains, like you see in this picture. So new irrigation systems, subsidies for fertilizer, new seed varieties, and so on and so on and so on. What was the effect? The effect is that it indeed had a lot of positive effects on agricultural productivity. Yields of the rice increased very much, and farmers, what did they do? They focused really all their energy and attention on these irrigated rice fields. They focused all the labor force there, and so they completely abandoned what they were doing in the forest, in the mountains, where they were clearing the forest to do shifting agriculture. So they abandoned these practices, and they left a lot of land which was able to naturally regenerate forest with, maybe not on the short term, but at least on the medium term and perhaps longer term, positive impacts on biodiversity. Okay, so that looks good, but we can just move south a little bit, not very far away, a few hundreds of kilometers further south, and we're still in Vietnam, but we're in the Central Highlands region in Vietnam. And a little bit later, the government said, okay, now we're going to focus a little bit on this region and do something about that region. And they basically adopted roughly the same kind of idea, where we'll boost agricultural productivity, and they focused on coffee, which is represented there, which, because it grows well, it's potentially quite a good region to grow coffee. And they applied the same kind of recipe, new agricultural techniques, new irrigation systems, new seeds, subsidies, and so on and so on. Results, the same to some extent, so agricultural productivity increased, yields of coffee increased very much, but what happened, completely the opposite of what happened in the northern region. There, coffee, instead of being able to spare some land for forest recovery, coffee started to expand very much at a very rapid rate, which encroached very much on tropical forest, and so led to a lot of deforestation in this region, which is also a biodiversity hotspot. So same kind of policies, completely different impact. Second example of complexity, the notion of leakage. So it's the idea that if you make some policies or interventions to protect some region somewhere, make it better for habitat, for biodiversity, change the practices, maybe you can have an impact there, positive impact there, but maybe you will move the pressure and you will displace the pressure on ecosystems to another place. And so this is something that has been studied, for example, a lot in the Brazilian Amazon region, because it's a biodiversity hotspot with a lot of deforestation, but also a lot of policies put in place to reduce deforestation. And so people have tried to look at surroundings of protected areas, surroundings of farms that are adopting better practices or that are reducing deforestation, and see, okay, if is there a deforestation that is moving in the neighborhood of these places where there's interventions. And they can find some evidence of that. Sometimes the effect goes in the other direction, so when you put a protected area somewhere, people decide that they don't want to deforest around anymore, so it's even better. So you have different effects in different directions, but the point is that when you look at the surroundings of the protected area or the intervention, you can identify if there is a leakage or not. But then people say, yeah, okay, this is still within the Brazilian Amazon. The further you go away, it's more complicated, and people started to say, yes, but if you really scale up the conservation efforts in the Brazilian Amazon, then in reality what we may expect is that agricultural investors, farmers, supply chain actors who are willing to expand agriculture and increase production, maybe they will move further away. They will move to another region in Brazil, which is the Cerrado, which is a savanna region, which is also a biodiversity hotspot, but much less protected. And so people may move there. And we do have a little bit of evidence, some kind of statistical evidence to show that, yes, to some extent this may be happening, but it's not totally clear. But then people were saying, yes, that may be happening, but in reality we do have some clues that people may be moving even further away. For example, in the Chaco region in South America, too, which is also a region of dry forest, which is also a biodiversity hotspot, and which is also, to a large extent, not very much protected. And there, the evidence to show that there is indeed a displacement of the pressure from Brazil to this region, it's even harder to see. We can see that there is a lot of deforestation in this region. You can see that there is a lot of agricultural expansion, but is it really because of the people are moving from one place to another? That's difficult. We do have some evidence from interviews, some people trying to see if people are actually moving from one region to another, but it's complicated. And it goes even further, because we do have some kind of insights, some clues, some kind of discourse or policy reports which say, oh, but in reality, a lot of South American actors would be very much willing to move even further, for example, to the Miombo regions of woodlands in Southern Africa, Eastern Africa, which is also a biodiversity hotspot, although we know very little about it. Well, among other reasons, because of the increasing conservation efforts in Latin America. But the point is that the further away you go and the broader you look, the more it's becoming complex and complicated to actually see that there is or not a signal of leakage from your conservation efforts, because the more you expand the scope, the more you have multiple factors, global markets, institutional factors, international agreements, and so on, which contribute to your decision and to the decision of investors and agricultural companies to move to these different regions. Okay, so that was my third point. So far with that, it's not necessarily super positive, but I will try to rapidly say 3 points about responses, but I know that we will discuss this much more in details in the afternoon, so I'm only kind of opening a little bit the discussion here. The first is, I've seen that, I have said that land systems are complex, that land use change processes are complicated, and that you have sometimes a counterintuitive effect to your policies, or you have complexities due to international trade. That's good, but it doesn't mean that we are completely blind. In reality, we can, and we increasingly are improving the understanding of the different mechanisms through which these kind of processes operate. So we can try to analytically decompose these complex processes into different kinds of mechanisms that we can trace and that we can identify, for which we can identify the conditions under which they may happen or not. So if I quickly return to the story of leakage that I was mentioning before, we can try to decompose this leakage process into a set of different mechanisms. So let's say what happens if you have a policy which restricts land use to conserve biodiversity in one place. Well, what is going to happen, a likely effect, is that it's going to restrict the amount of land available for example, expanding agriculture. So it's going to probably increase the land price in this area because there's less land for all the people who would like to have land to expand agriculture in this area. Some producers, some farmers who may be doing this, who may be doing agriculture in that place, maybe they will have to stop, so they will lose their land. So, okay, so if we can identify a number of, that we are in a certain set of conditions, I will not describe all the conditions in detail, but for example, if we are in a region where there is very little opportunities for these farmers or these wannabe farmers to do something else, there's not so much off-farm economic activities. If we are in a situation where these people can easily move from one place to another, maybe because it's in the same country, they can move to another place in the same country, or maybe because there's not so much barrier for international movements in this region. If you have people who really have some kind of cultural norms that they want to continue farming because it's part of their identity, and if you have another place nearby where you do have some land which is available and which is not protected, then you are likely to have a mechanism of leakage that we can call activity leakage. So the same people that were affected by the policy, they will pack their stuff and leave to another place, and they will maybe clear forests to another place to do agriculture. Okay, that's one mechanism, but you do have other mechanisms too. If your policy is really restricting land use in one place, it's going to restrict the production of some goods that are produced in this region. It could be some kind of agricultural products, coffee, soybean, wheat, doesn't matter. If the intervention is really strong enough, you can have an effect on the market. On the market price of this crop, there's less of these products being produced in this region, so it's probably going to increase. It's going to increase price of this product because you produce less of this, and the demand a priori has not changed. So what's going to happen if the demand indeed doesn't change? So it's a product that people still want to consume, or it's a product that really they have to consume. Let's say it's a staple crop, a cereal that really people need to live. Then it's probably going to have an impact on other producers somewhere else. So it's going to create a mechanism of leakage that we can call commodity or market leakage. So some producers in another part of the planet will be incentivized to produce more of this crop because the prices have increased. So maybe they will, in another part of the planet, they will clear land, deforest regions to expand agriculture to produce more of this crop. So it's a different mechanism of leakage. Of course, they could happen together. I'm not going into the detail of all the other mechanisms of leakage, but the point is that we can decompose these different mechanisms, and for each of these we can identify what are the conditions under which they are more or less likely to happen. Same, very quickly, to return to the story of land sparing and rebound effect in Vietnam. So we do have reasons to understand why is it that in the case of paddy rice intensification, irrigated rice intensification in northern Vietnam, this led to a phenomenon of land sparing, so land abandoned and restored and natural regeneration on this land, because paddy rice cannot really expand very much, it's very constrained, it has to be in flat land, irrigated, it requires a lot of water, it's producing rice, which is a staple crop in the mountain regions. People eat rice, okay, but when the self-sufficiency for rice in the village is achieved, they don't really need to produce more, and so on. Compared to coffee, where in the Central Highlands region of Vietnam, which was the second example, in this case of coffee, you have much less constraints on expansion, so basically if the crop is more productive, we can just produce more. It's a cash crop which is sold on the global markets, so basically the more you can produce, the more the global market can buy coffee, so there's no, basically the sky is your limit in terms of production, so you end up with a rebound effect, so the more productive and profitable your agriculture is, the more you will expand. So, okay, the key point is we can have some kind of contextual generalization of different mechanisms that can happen in land systems under certain kind of conditions, and so these mechanisms, they can serve as basis for theories of change. So we can say, okay, if we put some kind of policy in place or some kind of interventions, and we are in a certain kind of conditions, we are more likely to get this kind of effects than others. Second point, I will go very quickly because I'm essentially repeating what Jean-Pascal has just said. This is the graph displaying the SDG, the Sustainable Development Goals, and we have some analysis showing that if we look at land use is really connected